Find area 1 in feet squared. In this problem, a crest vertical curve spans from point A to point C. Also, a straight line connects point A and point C. The problem asks to find the shaded area between curve AC and line AC in square feet. The problem also provides the stationing and elevation for points A and C, as well as the grade of the curve at point A and point C. For this problem, we'll define two equations. Equation y1 will equal the equation of the curve AC, and equation y2 will equal the equation of line AC. This way, area 1 equals the integral of y1 minus y2 dx when evaluated from station A to station C. Since we're integrating over the horizontal distance, dx, we'll determine our equation for y1 and y2 as functions of variable x. We'll first determine the equation for y2, the straight line between points A and C. The problem statement shows the elevation of point A and the elevation of point C both equal 225.0 feet. Therefore, the equation for y2 equals 225.0 feet. The equation for y1 defines the curve AC as a function of x. The equation for a vertical curve is y equals r over 2 times x squared plus g1 times x plus the elevation at the beginning of the vertical curve. In this equation, r is the rate change of slope, which equals the final grade, g2, minus the initial grade, g1, divided by the length of the curve. We can add a subscript AC to identify this length is the length of curve AC. This length equals the station at point C minus the station at point A. And after plugging in those given stations, length AC equals 2.5 stations. Next, we'll substitute 2.5 stations for the curve length, as well as the values for grades G1 and G2. And this makes the rate change of grade equal to negative 1.6% per station. Back to our equation for y1, the variable g1 refers to the initial slope of the curve, which is given as positive 2%. And the elevation at the beginning of the vertical curve is the same as the elevation at point A, which is given as 225.0 feet. After making these substitutions, the equation for curve AC is y1 equals negative 0.8 times x squared plus 2 times x plus 225 feet. Next, we'll substitute equations y1 and y2 into the equation for area 1, which simplifies to the integral of negative 0.8 times x squared plus 2 times x dx, evaluated from station A to station C. After taking the integral, the area equals negative 0.267 times x cubed plus x squared, evaluated from station A to station C. If we define a coordinate system such that the origin is positioned at point A, then station A is located at x equals 0 stations, and station C is located at x equals 2.5 stations, which comes from station 18 plus 50 minus station 16 plus 00. Evaluating the expression for area 1, we get area 1 equals 2.08 station feet. The units are in station feet because when evaluating the integral, the x term is in units of stations and the y term is in units of feet. Multiplying this area by a unit conversion factor of 100 feet per station, Area 1 equals 208 square feet. When reviewing the possible solutions, the answer is B.